In the loading area behind a large grocery store, a forklift operator was preparing to exit a cargo truck container when the loading ramp suddenly disconnected. At the same moment, the truck moved forward, causing the forklift to tip backward and fall, with the operator flipping inside the cab. This incident clearly demonstrates the catastrophic consequences of unsecured loading ramps and trucks moving during forklift operations. All truck loading and unloading operations require loading ramps or dock plates to be securely positioned, chained, or mechanically locked, preventing movement or collapse during equipment transit. Ramps must be rated for forklift weight with adequate width, proper angle, and non-slip surfaces. On a farm, workers were installing a mini grain silo using a makeshift wooden pulley system to manually raise it into an upright position. As the silo neared vertical, the wooden support structure holding the pulley system failed and collapsed, causing the heavy silo to fall onto several workers positioned below. This incident clearly demonstrates the catastrophic dangers of improvised rigging systems and inadequate structural engineering for heavy lifting operations. All lifting operations require properly engineered equipment, including rated hoists, cranes, gin poles, or mechanical systems designed and certified for specific load weights. Improvised wooden structures cannot safely support heavy loads and will fail unpredictably. In a cargo van yard, a worker was crouched in a low position, repairing something near the facility fence, when a reversing truck slowly backed into the area, crushing him against the fence structure. The driver never noticed the worker's presence and continued the parking maneuver, completely unaware of the ongoing crushing. This incident clearly demonstrates the catastrophic blind spot vulnerabilities during backing operations and the fatal dangers of workers in low positions becoming invisible to drivers. All commercial vehicle backing operations require spotters actively guiding drivers and continuously monitoring blind zones where workers, obstacles, or hazards disappear completely from driver view. At a demolition site, a worker was forcefully attempting to remove a concrete slab from a wall structure when the entire section unexpectedly broke free, collapsing and burying him beneath heavy concrete debris. This incident clearly demonstrates the catastrophic dangers of uncontrolled demolition and inadequate structural assessment before material removal. All demolition operations require engineering evaluation, identifying structural dependencies, load-bearing elements, and potential collapse zones before any material removal begins. Workers must never forcefully pull, pry, or stress structural components without understanding what those elements support. Removing one section often triggers progressive collapse of connected materials. At a recycling facility, a forklift carrying an excessively heavy stack of scrapwood planks and metal sheets suddenly tipped forward when the operator stopped the vehicle. The unstable load spilled out completely, and the forklift then tipped backward as the weight released, damaging the vehicle. This incident clearly demonstrates the consequences of exceeding forklift load capacity and improper load center distribution, causing loss of stability. Mixed materials like wood and metal create uneven weight distribution, making the center of gravity difficult to assess and increasing instability. Sudden stops, especially with heavier elevated loads, create forward momentum that can overcome the rear counterweight, causing forward tip-overs. In a metal works facility, a worker was inside a truck bed attempting to attach rigging to a thick metal slab for overhead crane lifting when the crane operator moved the equipment before the rigging was properly secured. The moving rigging struck the worker, pushing him off the truck bed. This incident clearly demonstrates the catastrophic consequences of inadequate communication between crane operators and ground rigging personnel, and workers positioning themselves in hazardous locations. All crane operations require established communication systems using radios, hand signals, or agreed verbal commands, ensuring operators never move equipment until ground personnel signal they are clear, and rigging is complete. In a residential neighborhood, a truck positioned in the middle of the road had a cable running across to a house at approximately chest height. A motorcyclist traveling through the area did not see the nearly invisible cable and rode directly into it, striking the line at neck level and narrowly avoiding decapitation. This incident clearly demonstrates the extreme hazards of cables, ropes, or lines crossing roadways or pathways at head/chest height and inadequate hazard marking. When temporary cables must cross traveled areas during construction, moving, or utility work, they require highly visible warning flags, barriers, flaggers stopping traffic, and elevation above all vehicle heights, including trucks. In a port parking lot, a crane was lifting a small observation deck with a worker standing beside it approximately 15 feet in the air during repositioning when the crane line catastrophically failed. The deck and the worker fell from height, crashing into a nearby house structure below. This incident clearly demonstrates multiple critical failures, including inadequate fall protection, rigging equipment failure, and workers riding elevated platforms without proper safety systems. All workers on elevated platforms or structures being lifted must wear full-body harnesses connected to independent fall arrest anchor points, preventing falls if rigging fails or platforms tip. In an automotive repair shop, a technician was inflating a tire while a co-worker stood nearby attending to another customer. As a vehicle approached the shop, the tire being inflated suddenly exploded with extreme violence, striking the technician with lethal force and injuring him severely. This incident clearly demonstrates the catastrophic explosion hazards during tire inflation and the absolute necessity of safety cages and proper procedures. Tires explode from overinflation beyond rated pressure, damaged sidewalls or beads failing under stress, corroded or mismatched rim components, improper bead seating, or split rim wheel assembly errors. In the compound of a construction contractor company during break time, an asphalt paver was preparing to exit the facility when its rear tire suddenly exploded without warning. The violent blast struck a worker standing several feet away, directly in the explosion's trajectory, knocking his hard hat off and throwing him to the ground. This incident clearly demonstrates the extreme explosion hazards of large, heavy equipment tires and the critical importance of maintaining safe distances from all pressurized tires. Heavy equipment tires operate at high pressures supporting massive weights, and failures cause catastrophic explosions, projecting blast waves, tire fragments, and rim components with lethal force across significant distances. At a metalworking facility, a scissor lift was fully extended with a worker on the elevated platform when an overhead gantry crane that had not been properly locked out moved and struck the scissor lift platform. The impact caused the scissor lift to tip over, throwing the worker to the ground from a significant height. This incident clearly demonstrates catastrophic failures in energy isolation procedures and the fatal consequences of multiple pieces of equipment operating in overlapping zones without coordination. All overhead cranes and mobile equipment must be completely de-energized, locked out, and verified immobile before workers position elevated platforms or personnel beneath or near them. Unlocked cranes can move from accidental activation, remote controls, other operators, or maintenance errors.